On page 21 today, there's a problem up at the top that's not new. We have a vertex form equation for a parabola here. I want you to start by jotting down everything that you can tell me about the graph of this function. So this is something that we looked at towards the beginning of this unit. Jot down everything that you can tell me about that function. Just as sort of a refresher. Everything you can tell me about this function right here. What's one thing that you can tell me about this function? The what are? The vertex? If I have vertex form, I can say what the vertex is. So my vertex would be 1, -8. I know the vertex since we have vertex form. What else can you tell me about this function? Yeah, I have a lead coefficient here, so I can tell that this is going to be stretched by 2. I think there's one more thing that you can tell me here. Which way does it open? You could find the y-intercept. We'd have to manipulate it a little bit. But I'm looking at just from what's typed on the paper. If I didn't do any work at all. Because my lead coefficient is positive, I can see without doing any work that this is going to open up. So it's going to look something like this. And again, if we did a little manipulating here, if we did some distributing to get it into standard form, we could find that y-intercept as well. Now, we've talked so far about standard form, vertex form, and factored or intercept form. What I want to look at today is how we can put something that has a number in front of x squared into factored form. Everything that we've looked at so far to change into factored form, if I flip back in my notes here, everything we've looked at so far has had a leading coefficient of 1, right? Nothing exciting in front of x squared. So today we're going to look at how do I handle putting something into factored form if the leading coefficient is 2 or -3. That's what we're going to look at for today. Okay. So factored form out of another sort of option for our trinomials. When a is not 1, how do we factor these things? So for our first couple of examples, the first type of problem that we're going to look at for today is if we have what's called a GCF. So GCF stands for greatest common factor. That means that there is something in common with all of the terms that I have in my quadratic. So if we look at example 1, my a value here, my lead coefficient is 2. My b value is -14, and my c value is 24. Those are all even numbers. That means that these all have a GCF, a greatest common factor, of 2. That means I could divide all of them by 2 with no remainders. Does that make sense? Like 6 and 9 would have a GCF of 3 because I could divide them both by 3 with no remainders. That's what we're looking for here. This is the first thing I want to look for anytime that I've got a lead coefficient, an A value that's not 1. Look to see if it's a GCF, if it's common to all those terms, if I could divide it out of all those terms. If I can divide it out of all those terms, then that's what we're going to do. So we're going to factor out our GCF here, and that would leave me with x squared minus 7x plus 12. When we say we're factoring out our GCF, what we're doing is dividing that number out of all of our terms. So we get something a little bit simpler. Now, the 2 doesn't just disappear. Remember that A value gives us important information about the shape of our function. Okay, so I don't want to just throw it away. What I want to do is stick it in front. Okay, it's an important part of my function. We're going to stick it in front. It's just like our 2 is kind of stuck in front of our vertex form here. And now, with what's left, I don't have a number in front of that squared anymore. My A value is back to 1, so I can factor this just like we did last week. So I'm looking for factors of 12 that would add to negative 7. Factors of 12 that would add to negative 7. What do I want? Make one adjustment for me. Negative 4 and negative 3. So this would be x minus 4 times x minus 3. And for our factored form, don't forget that 2 in front. Since we started with standard form, we know our y-intercept is 24. And now that we've got factored form, we can see our x-intercept would be 4 and 3. And then because we can see that A value here, both in standard form and in our factored form, we know that we're going to be stretched by 2. So we're going to be kind of narrow. And since that 2 is positive, we're going to open up just like that warm-up problem. For example 2, same idea. Okay, so for our second example here, I've got negative 3x squared plus 3x plus 18. As a general rule of thumb, anytime that my lead coefficient is negative, I'm going to divide everything by a negative. Okay. In this case, since I could divide all of these by 3 with no remainder, my GCF is going to be negative 3. If I didn't have negative 3, it were just negative x squared, I would still divide a negative 1 out as a GCF. Okay. I want that x squared term to be positive. So if I see a negative in front, at the very least, I'm going to pull a negative 1 out as a GCF. In this case, all of these I can divide by 3. So I'm going to divide out a negative 3. That would leave me with x squared minus 1x. Remember, since we're dividing by negatives, these signs are going to change. And then minus 6. Now I want factors of negative 6 that would add to negative 1. What could multiply to get negative 6, but add to get negative 1? Swap the signs for me. There you go, because I want them to be negative 1. I want the 2 to be positive and the 3 to be negative. So this would be x plus 2 times x minus 3. So there's my factored form. My y-intercept, remember we get from standard form, that would be 18. And my x-intercept come from factored form, so negative 2 and positive 3 for my x-intercepts there. What is that A value? I have the same one in standard form and in factored form. What does that A value tell me about the shape of my graph? It's going to go down, and anything else that we know about it? It's going to be stretched out, yeah, stretched by a factor of 3. Okay, so one option is that we have a GCF that we can pull out. If I see a number in front of x squared, I'm going to check to see if it's a GCF and I can factor it out of each term. If I can factor it out of each term, then I'm left with something that's just x squared with all the stuff that we're used to from our earlier factoring. Now, the other option is that that number in front is not a GCF. Okay, so that's what we're going to look at next. I'm going to show you another strategy to be able to factor terms where I'm going to be stuck with that number in front. It's called AC method. And we're going to look at that with a few of the problems on the next page. So on page 22, if I look at example 3, I've got a lead coefficient and A value here of 3. Now I could divide 3 out of 12, but can we evenly divide 3 out of 16? No, that means that 3 is not a GCF. So if I have an A value here that's not a GCF and I can't just divide it out, we're going to have to take another approach. The one that I'm going to show you first is the AC method. This is not the only approach that you can take, but having taught Algebra 2, it's the one I find people to tend to remember and that tends to work for most people. So I'm going to show you AC method first. Now here's why it's called AC method. Remember that this is our A value, this is our B value, and this is our C value for standard form. So it's called AC method because we take our A value and our C value and multiply them together. So 3 times negative 12, that would give us negative 36. And then what we're going to look for are factors of negative 36 that add to our B number. So I get one extra step, but then it kind of looks like something we've done before. So I want factors of negative 36 that add to negative 16. You might need to make a list for this one. For this first problem, I'm going to go ahead and make a list on this one. If you found those factors already, that's great. This would be negative 1 times 36, or 1 times negative 36, negative 2 times 18, or 2 times negative 18. Oh, I'm going to stop my list here. Why would I stop my list here? I have them already, right? I don't need to keep going if I have them already. I don't need to make the whole list if I've got the ones that will add to negative 16 in the first couple. So I want 2 times negative 18. Now here's where this is going to be different. Before, we said, don't write this part down, okay? Don't write this down in your notes because you'll have to erase it. Before, what we said was, okay, that means I've got x plus 2 times x minus 18, and there's my factored form. Here's the problem with that. If I distribute this back, I have x squared minus 18x plus 2x minus 36. If I combine my like terms, I have x squared minus 16x minus 36. Is that the same as what I had originally? No, I need a 3 in front of here, and this is not supposed to be 36. Okay, so I can't do exactly the same thing that we did before. Here's where this is going to change a little bit. I'm going to rewrite this middle term using the factors that we picked. So 3x squared, here's where I want you to start following along with me again. 3x squared plus 2x minus 18x minus 12. So I took that middle term and spread it apart using the factors that we picked. Now here's what I'm going to do. That GCF thing is going to come into play again. I don't know how to factor stuff that's 4 terms right now. But what I can do is split this up into groups and look for a GCF. So if I look just at this first part right here, what do these 2 terms have in common? They both have a what? An x. So that's my GCF. I'm going to divide x out of each of these. That would give me 3x. I used to have 2 of them, now it's just 1, plus 2, because I'm taking the x out. Now do the same thing here. what do these terms have in common? I could divide them both by 3 would work. Something a little bit bigger works too, though. 6, yeah. And since this guy's negative, I'm going to do a negative 6. So negative 18x divided by negative 6 is 3x. Negative 12 divided by negative 6 would be positive 2. So I divided both of these by the biggest number that I could. And now I want you to look at that stuff that's in parentheses. See how it's the same? Okay. So this is actually my new common factor for this term and this term, right? I've got this in both terms. So we're going to factor it out the same way we pulled out an x from here, the same way we pulled out negative 6 from here. We're going to pull out 3x plus 2. And then I'm going to write what's left over. What's left over would be x minus 6, the stuff that wasn't in parentheses. There's my factored form. And let me check this one with distribution. So if I distribute, I would get 3x squared minus 18x plus 2x minus 12. If I combine my x's in the middle, I would have 3x squared minus 16x minus 12. And that was my original problem. So I know that that's my correct factored form. Again, this is what we call AC method. Okay? So for the majority of our problems where I can't pull out that A value as a GCF, I'm going to work through AC method. Okay? It is possible to do this sort of guessing and checking, but what I find is that for most people, we get sort of lost in the weeds on guess and check. So later on in our factoring work, I'll do some of these with guess and check, but for today, I'm going to stick with AC method. So this is my factored form here. Example 4, same idea. Okay. My A value is 2. Is 2 a GCF for this problem? Can I divide every term by 2? No, because these guys are odd, so I can't divide those evenly by 2. So what we're going to do is take our A and our C and multiply them together. So 2 times negative 9, that gives me negative 18. And now I want factors of negative 18 that add to 3. What factors do I want? Factors of negative 18 that add to 3. 6 times negative 3, that will do it. So I'm going to use these numbers to split apart the middle term. The 2x squared stays exactly the same. And then since you gave me 6 and negative 3 in that order, that's the order I'm going to use. If you had given me negative 3 and then 6, I can put it in that order too. That doesn't matter. So plus 6x minus 3x. Remember, I'm rewriting this middle term. And then the n stays the same, so minus 9 at the end. And now we're going to split this into 2 groups, first 2 terms and second 2 terms. And we're going to look for the GCF for each of those groups. So I'm ignoring the end of this problem right now. What is common? What's my GCF for these first 2 terms? I could divide them both by 2. And then what else do they both have? An x. So 2x is my GCF there. If I divide this guy by 2x, I'm left with just x or 1x. If I divide this guy by 2x, I'm left with 3. And now I'm going to do the same thing to my next group, my next set of terms here. I can divide both of these by what number? Negative 3. Since it starts with a negative, just like we talked about at the beginning, I want to use that negative as part of my GCF, so negative 3 here. That would leave me with a positive x, or 1x. And then negative 9 divided by negative 3 would be positive 3. Again, see how my stuff in parentheses is the same here? Anytime I'm using AC method, that stuff in parentheses should be the same. If it's not, I want you to go back and double check your GCF and double check that you divided it out of both terms in your group. Now that stuff in parentheses acts like my GCF since it's the same in both parts. And then I'm left with 2x minus 3. From here to here, in my opinion, is the easy part of these problems. I know I'm going to have that stuff in parentheses that comes out, and then I know I'm going to have whatever's not in parentheses that makes up my other factors. There's my factored form. Let's take a look at our next example here, example 5. Do I have a GCF for the whole term? Is there anything I can divide all of those numbers by? No. So I'm going to use AC method. So A times C would be 9 times 2. That gives me 18. I want factors of 18 that add to 9. Positive 6 and positive 3. So I'm going to use these factors to split up the middle. That gives me 9x squared plus 6x plus 3x plus 2. Remember, my first term stays the same and my last term stays the same. And now I'm going to break this up into 2 groups. And I'm going to look for the GCF for each group. For my first group, can I divide 9 and 6 by the same number? What can I divide them both by? 3. They have a GCF of 3. And then again, I've got x and x in both of these. So that means I can pull out an x as well. So 3x would be my GCF there. And then when I divide 3x out of each term, 9 divided by 3 is 3. X squared, divide out an x, leaves me with just an x. 6 divided by 3 would give me 2. And then x divided out, we've got no more x here. How about my second group now? They don't both have an x, so I know I can't pull out x as a GCF. Is there anything I can divide 3 and 2 by? Can I divide them both by 3? Can I divide them both by 2? So when you have a situation like this where there's no what I call exciting GCF, we're just going to pull out a 1, which is kind of lame. Oh, they have a GCF of 1. Well, everything has a GCF of 1. But I need to pull out something here. So if you don't have anything fun and exciting to pull out, we're going to pull out a 1. And then when I divide this by 1, it's still 3x. When I divide this by 1, it's still 2. Now my stuff in parentheses is the same. So that comes out as my GCF. 3x plus 2 is common to both of these. And then left over, I have 3x plus 1. There's my factored form. Question for me. I want you guys now to try example 6 and example 7. Try example 6 and example 7. Okay, let's take a look at example 6. What's the first thing I want to do on this one? There's one thing I can do before that. Yeah, I can actually divide all these terms by 2. That would give me x squared plus 9x minus 10. And then when I divide out that GCF of 2, this becomes something we could factor like when we started factoring. So factors of negative 10 that add to 9. What factors do I want? Factors of negative 10 that add to 9. Plus 10 times negative 1. So that would be x plus 10 times x minus 1. Don't forget your 2 in front there. Now, if you didn't pull that 2 out to start, you probably got something like, oh, maybe 2x plus 20 times x minus 1. Or maybe you got x plus 10 and 2x minus 2. Here, we have a GCF of 2 that we could pull out to get our same factored form. Or same idea here, there's a GCF of 2 that we could pull out to get our same factored form. You would have an extra GCF in one of your factors if you didn't pull your GCF out at the beginning. For example 7, I don't have a GCF I can pull out at the beginning, so we're going to have to use AC method here. So that would be 6 times negative 2. That would give us negative 12. And then I want factors of negative 12 that add to negative 1. What do we want here? Switch the signs. Negative 4 and positive 3, good. So I would write this as 6x squared minus 4x plus 3x minus 2. And then I'm going to split this into groups. Just focusing on my first group to start, what's my GCF here? What could I divide both of these numbers by? 2. And then what else do they both have? X. So my GCF would be 2x. When I divide this first guy by 2x, I'd be left with 3x. When I divide this guy by 2x, I'd be left with negative 2. And then how about for my second group here? What do they have in common? Just 1. Yeah, this is actually like really similar to example 5, right? Nothing exciting in common there. So we just say 1. I would be left with 3x minus 2. I'm left with what I had originally. Now my stuff in parentheses is the same. So I pull that out. And then my other factor is what's left over. So 2x plus 1. And there's my factored formula. Questions for me on 6 or 7? Okay, let's take a look at our last example together. Do I have a GCF I can pull out at the beginning? Are all these numbers evenly divisible by the same thing? No. So we're going to have to use AC method here. So 4 times negative 25, that would give me negative 100. Our biggest number yet here. And I want factors of negative 100 that add to negative 15. For this guy, I'm going to want negative 20 and 5. 20 times 5 gives me 100. To get negative 100, one of them needs to be negative. To add to negative 15, I want negative 20 and 5. So this would be 4x squared minus 20x plus 5x minus 25. And then we split this into groups. My GCF for this first group, what can I divide both of those terms by? 4, and they each have an x, so 4x. When I divide this first guy by 4, unless it's just 1, x squared, take out an x, is just x, so 1x or x. And then negative 20x divided by 4x would be negative 5. For my second group here, what's my GCF? I can divide both of those terms by 5. So when I divide out the 5, that leaves me with x minus 5. My stuff in parentheses is the same, so I pull that out. And I'm left with 4x plus 5. And there's my factored form. Questions for me for today? Okay, so if I have a number in front of x squared, the first thing I want to do is see if it's a GCF, like what we saw in example 6. If it's a GCF for the entire problem and I can divide it out, then I'm left with something that we can factor using factoring skills we had before today. If I've got something like example 7 or example 8 or any of the other examples on this page, I can't divide it out of all terms as a GCF, then what we have to do instead is use that AC method, that new method for factoring that we talked about today.